This is MAC 1105, Section 1.7, Part 2. In Part 1, we looked at interval notation. In Part 2 here, we're actually going to solve these inequalities. And inequalities are solved the same way we solve regular equations, but there is one major twist, and that is when you multiply or divide by a negative, you must change your inequality sign. When you multiply or divide by a negative, you must change your inequality sign. Meaning if I have something like negative 2x is less than or equal to 10, divide both sides by negative 2. As soon as you divide by negative 2, that inequality sign must change. It becomes x greater than or equal to negative 5. If it had 2x less than negative 10, we are not going to divide by a negative. Yes, there's a negative in the problem, but it's the dividing by a negative. We're dividing by a positive. We don't make any changes. So let's take a look at some simple examples. This is your regular subtract 10 from both sides. We have 2x is less than 10. Divide both sides by 2, so x is less than 5. Now your directions will ask you to solve, which we just did. Graph, put a 5 here, less than will shade to the left, and because it's plain old less, it is a parenthesis facing in the direction of the arrow. And the interval notation for this, remember the 5 is at the backside parenthesis, so it's the back there, and it is going forever and ever and ever to the left, which is negative infinity. So all three of those would be your solution. On MATLAB, you'll have to type this in, but there will be graphs for you to choose in a multiple choice format, and then you will have to enter the interval notation. Another simple two-step, add 4 to both sides. We have negative 3x greater than or equal to 15. Solve by dividing by negative 3. And what I suggest is grab hold of that inequality, make the change, and then go back and do your arithmetic, because half the time you forget to make the change later on. 15 divided by negative 3 is negative 5, less than or equal to negative 5, shading to the left. It is less than or equal to, so it gets the square bracket, facing the same direction as the arrow, and my interval notation on this is negative infinity up to negative 5 with a bracket. This is just a matter of distributing and then combining before you solve. So on the left side, all I could do is distribute, and then I can combine the 2 and the 4. Get your x's together by subtracting 3x from both sides. Subtract 6 from both sides, and we have x greater than or equal to 0. So 0 is on the number line. Greater than or equal to shades to the right. It is greater than or equal to, so it is a bracket, which makes my interval notation 0 to infinity. This one's got a negative to distribute, negative 4x minus 8, greater than 3x plus 20. I'm going to add 4x to both sides, gives me 7x plus 20. Subtract 20 from both sides, and then that's a positive 7x. I'm going to divide by 7. And be careful that you just don't suddenly bring your x over to the left side. Our x's were on the right. They need to stay on the right. So this is x, and that's negative 4. Now for graphing purposes, it would look better, be easier for you if you swap this around now. So if you put x on this side and you put negative 4 on this side, you must maintain the meaning of the inequality. This is negative 4 greater than x, which is the same thing as x less than negative 4. So negative 4 on the number line, less will shade over to the left with a parenthesis because it's plain old less, which will make our interval notation, starting with the back parentheses, negative 1 to negative 4. With a fraction, I've gone ahead and separated this out just to make it easier to see. We know when you've got fractions in the equation, we want to get rid of the fractions by multiplying by the common denominator. The least common denominator for 2, 3, and 6 is 6. So all I did here was spread this out. I also took the binomials and put those in parentheses because oftentimes you're going to have to do some distributive property after you cancel. So we're going to multiply this by 6, this one by 6, and this one by 6. And then because it's spread out, you can see the canceling a little better. 2 goes into 2 once, 2 goes into 6 3 times, and then distribute 3x minus 24. Had you not put the parentheses right there, you might not have distributed. Bring your inequality sign down. 3 goes into 3 once, 3 into 6 twice. Distribute 2x minus 8. And over here, the 6's cancel, plus 1. So we've gotten rid of the fraction pretty easily. The next thing is combining on each side. There's no combining we can do on the left side. But on the right side, I can put negative 8 plus 1 together to give me negative 7. And then solve. Subtract x from both sides. Subtract 2x from both sides gives me x. Add 24 to both sides, and I have x greater than or equal to 17 is my solution. 17 on the number line, shading to the right with a bracket because it's greater than or equal to, and that is my interval notation. Bracket 17, going forever to the right, means infinity. Here are a couple of those compound inequalities. We could separate this out, but it's a whole lot easier just to look at the middle part, thinking I need to get the x alone. I'm trying to get it to look something like, I'm just making this part up, this is not going to be my answer. We need to get the x alone into this format. So I want to subtract 4, not just from both sides, but from all 3 parts. So 6 minus 4 is 2. The 4's cancel, I get 2x. 12 minus 4 is 8. Keeping an eye on the middle, I want to get the x alone, so divide by 2, divide that by 2, divide that by 2. So 2 divided by 2 is 1, less than or equal to x, less than 4. We're ready to graph. We have a 1 here, we have a 4 here. Our x is located between 1 and 4, so we shade between 1 and 4. Now this is a little strange. This is less than or equal to, so we're going to get a square bracket here. This one is just less, and we get a curve. So it's entirely possible that these are not exactly the same symbols. Interval notation, bracket 1, comma 4 with the parenthesis. This is a compound inequality, but it also has a fraction right here. Ordinarily, I've been saying to you, when you see fractions, get rid of them from the beginning. But in a problem like this, when you have one solitary fraction that happens to be the coefficient in front of the variable, I think it's easier to start with that negative 5 there. Let's add 5 to this part, and this part, and deal with the fraction later. Negative 3 plus 5 is 2, less than or equal to 2/3 x, less than 4. The easiest way to get rid of one fraction coefficient in front of the variable is to multiply by the reciprocal, because the 3's cancel, the 2's cancel, and you'll be left with the x, which is what you want. So we're going to multiply all 3 of these by 3/2. So 2 cancels, and I'm left with 3. In here, the 3 cancel, the 2 cancels, we get x. And here 2 goes into 2 once, 2 goes into 4 twice. 2 times 3 is 6. So there is my solution. My graph will go between 3 and 6 with a bracket on this one and a parenthesis on this one. And then my interval notation is a bracket with the 3 going to the 6.